Okay, sometimes I get ideas about things that are related to art, but they're not exactly art. And something that I've always liked to think about is the way scientists see, like, the universe. And at one point I was looking at books that mathematicians had on topology, which I don't understand the mathematics very well, but I got ideas for shapes of things from those books. And this one is one where I puzzle over, sometimes wondering whether this is what could be going on with a black hole. Not saying that this is what's going on, but I decided to share it to see if it made any sense to anybody else. So what the idea has to do with is this Klein's bottle, which is a pretty well-known shape that has only one surface. It's like a Mobius strip, and it only has one surface. So if you went in here and traveled down through the neck, then you'd be here, which is like the inside. But if then you come back, you go out and you're on the outside, but you're only on one surface. And the part that's strange to me about that one is the fact that it goes through the side. And I think that that's an interesting part of the Klein's bottle. So I started tinkering with ideas. First, nobody knows for sure what goes on once you go into a black hole. And a one-dimensional version of it is this shape here. And then the black hole they call a singularity. So I was wondering if when matter goes into there. One time I saw an article in Scientific American which indicated that space-time is reversed once you cross the horizon, the event horizon, that space-time is reversed. And by thinking about that, I was thinking, well, maybe once you're inside a black hole, it's another universe, and it's just like inside out from this one. So once you're in there, you look back at our universe, and our universe looks like a black hole when you're in there. And I was thinking, if that were the case, possibly the great voids, there might be another curvature of space that's the opposite of the one as you go into a black hole. And I was thinking, where would that be if that was in our universe? And I was thinking it could be the great voids that are between the galaxies. When I see these maps of the sky of the universe, the galaxies are like gathered along the edges like soap, like bubbles, like the skin on the edge of a soap, and the galaxies are all gathered along the edge, and there's these great voids. So I was thinking it's possible that matter enters our universe in a place that's curved the opposite way and flies apart, and then eventually ends up gathering together and then going down the black hole. So the idea is that it's like a convection cell in a pan of hot water. The heat rises, and then the cool drops down, and it causes a convecting cell. So it's a way for energy to transfer from one place to another. And in the universe, I was thinking that was a possible thing that was going on with black holes. This is a Klein's bottle that I drew, and I decided to pretend that this place where it cuts the surface is actually a singularity, coming from either way, whether you're going down here or whether you're coming up here and going there. One way or the other, you flip to another side of you're inside the singularity or you're outside the singularity. And then when I drew this one, I decided it was a little bit hard to see. So I drew this one, And on this one, I moved the 2 points. These 2 points were connected at the singularity there. Now I made 2 singularities, and when matter drops down here and hits that singularity, all of a sudden it's on the outside of the Klein's bottle, and it travels on the surface out there. If it comes from here and hits the singularity, all of a sudden it's on the inside and it's traveling, and then it eventually convects back. So this would be like a convection cell. Stuff going here, boom, all of a sudden it's here. Then stuff going here, boom, all of a sudden it's there. And it just goes around and around like a convection cell. Now, that being said, I want to make sure that it's clear that I'm not saying that I think that things actually work this way. It's just a thought that I had, and I was thinking that if I put it on my YouTube channel, that maybe somebody could give me reasons why and why not this could work. Or it would really be interesting if a mathematician could tell me if this was even possible for a Klein's bottle to have this surface. If you could alter a Klein's bottle to make this shape, and that it would make sense mathematically. I'm not sure about that. It's just something that I could see, and I'd been thinking about for a long time, so I tried to draw a drawing of it. Alright, that's it.